is 1 minus 1 half x, and g of x is 1 negative 1 plus 1 half x. So let's see, if we graph those, let me think of where they're going to cross. You got 1, let me think. Okay, so
can I make g of x, would that be then also like 1 half x minus x?
yes, yes. So I think we need first and fourth quadrant. Where's it gonna? And x equals 0 is the y-axis. Yes, first and fourth quadrant. That's what we need here. Okay, so if we graph 1 minus 1 half x, so we have a y-intercept at 1 and a slope of negative 1 over 2. So that would be this line here. And if we graph negative 1 plus 1 half x, that's a y-intercept of negative 1 and a slope of positive 1 half. So that will look like this. And then it also told us that x equals 0, which is our y-axis. So right here is our area. Okay, this is not too bad. Lines, they kind of gave them to you in a little bit of weird fashion, but the base is just a couple lines that you have to subtract. What makes this problem much more difficult than the other ones we've done is this. The cross sections perpendicular to the x-axis are equilateral triangles. Okay, so when we think of area of a triangle, it is 1 half base times height. Here's the problem with that. If it's 1 half base times height, then you've got two variables there. And so we know we have an equilateral triangle, which means, like if I know that this side right here is x, and this is x, and this is x, but that does not mean that the height is x, right? The height here is going to be different than x. So we're going to have to get the equation for the area of an equilateral triangle. And once we get this once, you can use, if you memorize it, you can use it for every one you have from here on out. But just right now off the top of my head, and I've done this a lot of times, I can't remember what it is. So I have to work it out usually whenever I get one of these. So that height right there, whenever it's going to be perpendicular to the base, which is going to cut this base right here in half, making this little piece right here x over 2, and this little piece right here x over 2. And that makes a right triangle right there. So we could do Pythagorean theorem here. We could say x over 2 squared plus h squared equals x squared. And so this is going to be x squared over 4 plus h squared equals x squared. And we want to solve this for h because x here can be the distance between the, we can let that be our x or base or whatever you want to call it. So we need to solve for that h so we know what the height is. So we're going to have, we're going to subtract that x squared over 4. So we get h squared equals, here, this is like 1x squared minus 1/4 x squared. So what is 1 minus 1/4? 3/4. So we've got 3/4 x squared. And then we would square root both sides. So we'd get h equals the square root of 3 over 2 times x. We could have used trig there. You can see you got that square root of 3 over 2, which is a unit circle value. But I prefer Pythagorean theorem. So that's the height. So that means the area would be 1/2 times the base, which is x, times the square root of 3 over 2 times x, which is the height. And so if we put that together, we're going to get square root of 3 over 4 when we multiply those two fractions together, and then x times x is going to give us x squared. Yeah, so this is your area of an equilateral triangle. And if you memorize it, every time you have an equilateral triangle, you can use that formula. But it's usually not one people have stored away in their memory, so it's good to know how to get that too. So this is the area of an equilateral triangle. That's what we will be integrating. Okay? And that x right there, that is the length of that purple line right there that I have. Top function minus bottom function. So for this problem, we would integrate, and I'm gonna put that square root of 3 over 4 on the outside of the integral because it's just the coefficient, so I can do that. And then I'll have top function, which is 1 minus 1/2 x, minus the bottom function, -1 plus 1/2 x, and then we've got to square that. And what should our limits on our integral be? 0 to 2. And so let's simplify this here. If we distribute that negative, that's going to make that positive and this one negative. So we end up with square root of 3 over 4, integral 0 to 2 of 2 minus, you got a -1/2 and a -1/2, which is just going to give you x squared dx. So square root of 3 over 4, integral 0 to 2 of 4 minus, minus 4x plus x squared dx. And from here, let's just use our calculator to do that. You guys should be able to integrate it just fine. So we have the square root divided by 4. And so I got 2 square root of 3 over 3. Check and make sure you guys get the same. Yes. Yes. Okay. Questions? Okay. All right, here's your last one. In notes, yes. I might make you guys do inverse trig if gonna see. We're gonna review first before I throw that in there, because if we have some time, I might throw some inverse trig in there. But okay, so I think this one is difficult for multiple reasons. Not that the work's going to be that much harder than the other ones we've done. I think the most difficult thing about this one is that it does not give you an equation. Yeah. So you are kind of lost here in the beginning, but we should know how to write the equation of a circle. It doesn't tell us where the circle's at, whether it's moved up 7 to the left 4, any of that. So since it doesn't tell us where it's at, the easiest thing to do is to put it at the origin, right? So that means that our equation for our circle is just going to be x squared plus y squared equals the radius squared, so 5 squared is 25. Okay, so that is your equation of your circle. So if you graph it, you would just have this 5, 5, negative 5, and negative 5. You would just have my 5 here. You just have the circle here. Just find the volume of a solid with a semicircular base. So I'm only going to use half of this. With a radius of 5, whose cross sections, so it says cross sections perpendicular to the base are parallel to the diameter. Okay, so this right here, perpendicular to the base, just means that whenever you build each one of those cross sections, they're going to be standing up straight instead of like leaning over at a 45-degree angle or being crooked, right? So you're building, like if you think of your birdhouse, all of those cross sections are vertical, right? They're not like tilted 25 degrees or something. So that perpendicular to the base, although they're never going to give you anything that's not perpendicular to the base, because talk about making it much more difficult. I don't even know how to solve that problem. So they'll always be perpendicular to the base. That does not really affect how you do this problem. The parallel to the diameter tells you about your cross section. So here's the thing. On this problem, they don't tell you which diameter to use. So there's two ways you could do this problem. So I want to show you how. I'm going to show you the two different ways that you can do this. If I can get my computer to cooperate because it is not wanting to. Something's wrong with it, but oh well. Maybe this is not good. It's probably gonna quit on me. Let me hit save. Maybe it's wanting to quit. So maybe we'll get it together here in a second. So you could use the x-axis as your diameter. And if you use the x-axis as your diameter, then that means you would have cross-sections that are parallel to the diameter. So they would be horizontal, they would be perpendicular to the y-axis. So this would be in terms of y. Or you could use this vertical one here, and you would have cross sections that were vertical, in this case, perpendicular to the x-axis. So this is in terms of x. There is not really let me think. I don't think it's really going to be easier to do one rather than the other here. But we haven't done any in terms of y yet, so let's do this in terms of y. There is almost no difference between the two methods here because your equation's not solved for x or y yet, so it's not really easier to do one or the other. So if we look at this circle, and we want to do this in terms of y, that means we need to solve our equation x squared plus y squared equals 25 for our x. So we would subtract our y squared. So we'd have x squared equals 25 minus y squared. And we would square root both sides. So x would equal plus or minus the square root of 25 minus y squared. So that's really two equations. X equals positive square root of 25 minus y squared, and x equals negative square root of 25 minus y squared. And when we look at that, the positive part, that is your right-hand side of the circle. And your negative part right here, that is your left-hand side of the circle. So in the one on number 71 that you guys were doing for homework, we did everything in terms of x. So the positive was the top and the negative was the bottom. Since this is in terms of y, we're thinking positive is right and negative is left. So this is the right-hand side and the left-hand side. Here's the other thing I think is so tricky about this. What shape are your cross sections? Squares. And Joe proved my point about it being tricky because the semicircle in this case is the base. But when you see semicircle, you're thinking it's your cross section. So you got to be really careful with this. Your cross sections are squares. So our area formula that we are using is just side squared. Well, we could, but they didn't tell us that we did. They want a different shape. So, yeah. So, and we need to keep in mind, this only asked for a semicircle base. So we're only looking at like the top half. Or you could do the bottom half if you want, but why do negatives when you don't have to? So we're only looking at the top half of this equation. So if we are doing this in terms of y, we're going to do right minus left. Okay? Instead of top minus bottom, it's right minus left when you're in terms of y. So we will integrate, and then we'll have the right, which is the positive square root of 25 minus y squared, minus negative square root of 25 we're not dividing anything by 2 or anything here, because that the base of that square is that whole length between the 2. So we're just subtracting them. What should our interval be here?
From 5
0 to 5, because our interval has to come from the y-axis because we're integrating with respect to the y-axis. So 0 to 5 there. And so whenever we do this, this double negative here becomes a positive. So you're going to have the integral from 0 to 5 of, it's always like it's top minus bottom or right minus left. It looks like we are subtracting, but we're really adding, because whenever you do the minus, that left one is a negative, it becomes a positive. But you always do either top minus bottom if you're doing it in terms of x, or right minus left. So the function furthest to the right is this positive function here, and the function furthest to the left is this negative here. Which what it does is essentially you're taking this piece right here and you're adding this piece over here. But then you got to use the negatives because it like takes care of itself. The minus and then the negative in that equation will take care of itself there. So you'll get 2 square root of 25 minus y squared dy. The squared right here is there because our equation is side squared. And so that is going to give you 4 times 25 minus y squared dy. Yep. And at this point, let's just grab our calculator and do that. You can put the 4 on the outside if you want. I got 1,000 over 3, or you could give 333.3 repeating. That. Okay. Questions? Okay. So, right now in class, I want us to do. Our book has hardly any questions on this. I want us to do 71, B, and D. We have not done a cross section like D, but I want you guys to try to figure it out. So I want you to work on these right now, then we're going to put those up on the board, and then once we get those done, I have an assignment that's going to review it starts into sort of test review sort of stuff.